Okay, welcome back. What I want to look at today is something called Kirchoffs Laws. Now, let me just make sure that we can see it. Did I put it in high definition? No, I did not. Okay. I'm tempted to, let me just try something in 1 second. Bear with me for a second while I see if I make this any bigger. Sorry. It's okay, we're just trying to see if I could make it bigger, to make it easier to read. Let me just try and see, because I need to make sure it is readable to everybody. Okay, right, so Kirchoffs Laws, okay, and just bring him back a bit, and let's just go in. Okay, back a bit. So what I'm looking at is Kirchoffs Laws, okay, and what we have here is Kirchoffs laws relate to the calculations of current flowing through a closed loop circuit. It allows us to calculate the current in each resistive part of the circuit, where there is more than one source of EMF is being applied. Okay, so what we're saying here is that where there is more than one source, so you may have two power sources in supplying your circuit. Okay, that's what we're looking at and considering, and that's what we want to take into account. Okay, now it is important to remember that the current arriving at the junction of a circuit is equal to the current leaving it. So what we're saying here is that what goes in must come out. This means that the algebraic sum of the current must equal 0 at the point of the junction. Let us consider the following example. Here we have I1, I2, I3, I4, I5 in respect of Z1. Okay. Now you have current going into I1, I2, I3, I4, I5. Now the current somehow will dissipate itself from this junction to various parts depending on its value of resistance. Now please note that is my interpretation. You will need to find your own interpretation or your style of learning that makes it more comprehensible to yourself. Okay, and that is important that you understand that. And here we have the diagram again showing you I1. We say we have 5 amps here. I2 has 3 amps going through it. I3 has 4 amps. And I4 has 7 amps. I5 has 5 amps. So, let me see if I can make this darker. Yes, okay. I hope I've made it too dark that you can't see it. Let me see if I can put yellow on it. Okay, that might do it, I think, but I won't know till I look back at it, so bear with me. I'm just trying to make it more readable. Okay, so if we consider the algebraic sum of diagram Z1, which takes account of the current in sequential form, that is I1, I2, I3, and so on, the solution for that diagram will be I1 minus I2 minus I3 plus I4 minus I5 equals 0. To prove this, we can put in given values of I. And here, as previously stated, I1, I2, I2 minus I3 plus I4 minus I5 equals 0. And all we've done here is to put in those values that we have stated. Now, for me here, if we have current going in, we must have the same current coming out. So as you can see here, we got current coming in. I1 is coming in with 5 amps. I4 is coming in with 7 amps. When you add these two together, it gives you 12 amps. We've got 5 amps coming out, plus 4, which is 9, plus 3, which is 12. So we can see that the end result at the junction will be 0. From diagram Z2, we can see that I1 has a value of 5 amps, I2 has a value of 3 amps. Sorry, I missed my reading there myself, excuse me. Let me just make sure I got this over. Yes, okay. Etc. value of 7 amps. I5 has a value of 5 amps. We will then have 5, etc., which comes out at equals 0. Okay, as previously mentioned. Okay. Now this is for you to draw your diagrams yourself out and have a look. Do not leave it and think it will do itself. It doesn't work like that. Okay. Now when subtracted from each other, the result should be 0. I would like us to look at the mathematical application of solving simultaneous equations. We have equations which contain an unknown quantities x and y, which will appear in each side of the equations. Okay. Let me just drop this down a little bit, shrink it. I'm a little bit too far out, so I'm getting a little bit concerned that I might not be able to get it as I would like it to see it. Like you to see it, okay, I should say, rather. Let us look at an example. 3x plus 4y equals 11. Equation 1. X plus 7y equals 15. Equation 2. Now, if we multiply equation 2 by 3, what do we get? So what I've done here is multiply equation 2 by 3. And that equation 2 becomes equation 3. Okay? Therefore, give us 3x plus 21y equals 45. Now, I've rewritten it as equation 3 at equation 3 because it allows me to follow it in a sequential manner. Okay? But that's how I work. You need to find your own style of working so you can interpret and follow the information for yourself. For me, I wrote it so I can put it in a manner that comprehends to my brain as it makes sense. Okay? So we then going to subtract equation 1 from equation 3. Okay? And you can see that we had equation 1 here. So all I've done now is bring equation 1 down to here. 3 from 3 is 0. 4 from 21 leaves 17. And that is 17y. 11 from 45 leaves 34. Now I need to get y by itself. So what I do here, I divide both sides by, sorry, I'm surprised that I didn't put this into place actually. So let me see if I can get this up now. Let's change that. Give me you. Okay. What I then do now, I need to get y on its own. So I divide both sides by 17. I'm just trying to see if I can get this into divide both sides by 17. Okay. Divide both sides by, sorry, by 17. Okay. And that's what I've done here. So I divided both sides by 17. Okay. And that gives me y on its own. Okay. 34 divided by 17 equals 2. So therefore y equals 2. Okay. Just step back a bit and make sure that I got all this in. Okay. So you can see, can be seen. Okay. Okay. Now again, find your own style of learning, okay? And you can see here now to find the value of x equals 1, I've done a similar process. Now, here's the tricky part. To check these values are correct, we substitute them back into the equation. We use equation 2 for this purpose. X plus 7y equals 15. This is the original equation. In equation 2, we know x equals 1 and y equals 2. So the solution becomes 1 plus 7 times 2. We multiply by 2 because this is the value of y. And here we have both sides here now equal 15. It's therefore balanced. Okay? So we know the answer is correct. So we can see that the sum of x and y is equal to the sum of the circuit. This means that both left hand and right hand side must equal. Let us look at a negative simultaneous equations. Now this one here, I'm going to let you do for yourselves, okay? But let me just read this through to you. With these equations, we must eliminate one side so as to solve the other. Let us consider the following example. Calculate the following equation. The 2-volt source, now draw out the diagrams. The 2-volt source has an internal resistance of 1 ohm. A load resistance of 4 ohms is connected in parallel. Calculate A, the current in the 4-volt battery, B, the current in the 2-volt battery, and C, the current through the load resistor. Now here you need to draw out your diagrams. Always draw out your diagrams first, okay? Don't try to do anything else without drawing out your diagrams. It tells you, it tells the brain what you're expecting it to do. and what the brain now needs to get into the mode of being prepared for. Okay. Now I'm not going to go for this because I've just gone for this with you, but you can see that do I need to change this to make it brighter in any way? Or can I leave it as it is? Is it good enough? I believe it is, okay? But you can see the process here. Okay, let me just change one different color for this purpose here. So you can see that follow these processes in stage. Now do the process stage by stage, okay? Stage by stage, okay? Okay, you can see each one here, each stage has been taken 1, 2, 3, 4, 5, 6 stages in order to arrive at the given solution. And here's your answer, okay? Again, make sure you've calculated the answer for yourself and that you're happy with the process. Your answer is here, of course, okay? It's just my way of how I like to do things, and that's just how my brain works, okay? You gotta find your own brain working capacity, okay? Now, you need to write this out in order to aid your understanding and the concept of it. And when you write it out pen to paper, it allows your brain to recognize what you're asking it to do. And by doing that, you allow your brain to function in the way you expect it to function. It then makes the working out a lot easier. Okay? And here's another one. Let's consider a battery having an EMF of 105 volts and internal resistance of 1 ohm. This is connected in parallel with a DC generator having an EMF of 110 volts. The internal resistance of the generator is 0.5 ohms. These two EMF supplies a load resistance of 8 ohms. Calculate A, the current in the battery, B, the current in the generator, and C, the current across the 8 ohms load. Okay? That's something for you to do and to look at. And here's the process that I have shown and followed through. Okay? 105 equals 8. Open bracket I1 plus I2, close bracket, plus 1 plus 1 I1. Yeah, something like that. Look back at the diagram. Make sure, because this is your diagram here, okay? And these are your resources here that you're talking about. These here. These here, okay? And you have a generator here, okay? And that is your, let me just recheck, your 8 ohms load. That's your load, okay? That's the load. That's your load here, okay? Okay. Ignore my mess, okay? That's just me scribbling all over the place to try to highlight it and make it more visible, okay? So I'm hoping that it has worked. I'll try to run it through now. And here is to prove the answer is correct. That's here we have done that process here for you, okay? Okay, you can see that what we've done here is 8 plus 102 is 110, equals 110, so we know the solution is correct. Okay, let me just go on up, make sure that I got everything in play. Okay, so I'm just recapping now. No, don't ask me. I'm hoping that you can zoom in on this actually. And here we are. Okay, we're at the top. Okay. Thank you for your time. I hope you found this useful. Have a good day. Bye-bye.